Hello friends, in this video we'll be discussing Laplace transform, type number 1 basic problems, problem number 12 and 13. Welcome back friends, let's move on, let's go ahead. Till now we are done with 11 problem, now we are moving to the next problem 12 and 13. If you remember, till now we are done with cos square t, you know what to do, right? We have formula for that, 1 plus cos 2t upon 2. We have done with the cos cube, we are done with cos raised to 4. Now we are moving ahead and now we'll be solving cos and sin raised to 5. For that purpose, you need to remember Pascal's triangle. Obviously, you can do it with trigonometry, like sin raised to 5t can be written as sin square into sin cube. This is one option, obviously, you can do it. Then sin square can be further simplified, and again, sin cube can be further simplified and they can be multiplied. So, this is one option that you can obviously go for it, but I'll not prefer that. I'll prefer Pascal triangle. Doesn't make much difference. You can go ahead with any method you are comfortable with. So let's move on. First of all, let us discuss what exactly Pascal triangle is. Here we'll discuss Pascal triangle and we're gonna use that Pascal triangle here. So this Pascal triangle, you're gonna write it down on the last page of your formula list. So see here what exactly Pascal triangle is. It will start from 1, then we're gonna write down 1, 1. After that, the pattern will start first and last one fixed. First one, last one fixed. And here it will be addition of these two terms. So 1 plus 1 will become 2. Follow me, don't worry. 1 fixed, 1 plus 2, 3, 2 plus 1, 3, last one fixed. Next. 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, last one fixed. Next. 1, 1 plus 4, 5. 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, last one fixed, and so on. So you can go ahead, let me write down one more. 1, 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, and finally 1. And you can continue this list. Now, let me tell you what is the use of this Pascal triangle. First of all, what is the expansion of a plus b the whole square? It's actually a square plus twice ab plus b square. So this is the formula for a plus b the whole square. So if you observe this with this particular pattern, see here, these are the coefficients of this line is the coefficient of a plus b the whole square. See here, here you have 1, here you have 2, and here you have 1. 1, 2, 1. See here, 1, 2, 1. So this is the coefficient of a plus b the whole square. The same way, and actually, if I'm writing down in the proper way, here it will be b raised to 0, and here it is a raised to 0. Actually, b raised to 0 means 1, and a raised to 0 means 1. Therefore, I'm not writing now. Okay? Next is what? A plus b the whole cube. What is the formula? A cube plus 3a square b plus 3ab square plus b cube. This is the formula. Now see this line. This line will give you coefficient of a plus b the whole cube. How? See here. We have 1, we have 3, 3, and here we have 1. 1, 3, 3, 1. 1, 3, 3, 1. And actually here it will be b raised to 0, and here a raised to 0. Are you getting the pattern? Let's move on and let's try to write it down. A plus b raised to 5. So can you tell me which line is the coefficient of a plus b raised to 5? This one. This line will be the coefficient of a plus b raised to 6 and so on. So a plus b raised to 5 will be what? See the pattern here. Let me first explain you the pattern here, then you can easily form this. See here, it's very simple. Coefficients, we know how to write the coefficients, right? These are the coefficients. So in case of a plus b raised to 5, what will be the coefficients? 1, 5, 10, 10, 5, 1. These will be the coefficients in a plus b raised to 5, right? Now, initially, see here, the pattern, a first term, you're going to take this power, that is a square. So a square, with that, second term raised to 0. First term raised to this power, second term raised to 0. Then you're going to reduce this power. See, a raised to 2 will become a raised to 1. You're going to reduce the power, reduce. So a raised to 1 will become a raised to 0. And second one you're going to increase. 0 will become 1 and 1 will become 2. That's it. Not clear? See here. Just wait. See here. A first term is cube and second term b raised to 0. Reduce, reduce, reduce. 3, 2, 1, 0. Increase 0, 1, 2 and 3. Not yet clear? Don't worry. Let's try to write it down. A plus b raised to 5. See, the coefficients are very clear. So let me write down here coefficients. 1, then we have 5, then we have 10, then we have 10, then we have 5, and then we have 1. Coefficients we are ready with, right? What next? A raised to 5. With that, second term raised to 0. What next? You just need to reduce. 5 will become 4, 4 will become 3, 3 will become 2, 2 will become 1, and 1 will become 0. Is this clear? What next? Second term, b raised to 0 will become b raised to 1, b raised to 1 will become b raised to 2, b raised to 2 will become b raised to 3. You need to increase the power. Here it is 4, and finally here b raised to 5. So this is the way we're gonna write it down. A plus b raised to 5. Is this clear? If it is not clear, pause this video, go back and check once, then it will be very clear. This is the way we're gonna use Pascal triangle. So this is the use of actually Pascal triangle for writing down the expansions. Now my question is, why we are introducing a new concept? You might be thinking, sir, we can easily do sine square into sine cube. So why you are again making our life complicated with one more concept? But the problem is, if it is sine raised to 5, I am okay with you, I am with you. You can use sine square into sine cube. What if it is sine raised to 6? Okay, we can manage sine cube into sine cube, sine raised to 7, sine raised to 8, sine raised to 9. Then what? Then your life will be very difficult. At that time, you need to go with this. So let us do it in a generalized way. If it is 2, we know how to do it. Sine square, cos square, cube also we can manage. 4 we can manage. 5 or greater power than 5, we're going to use Pascal triangle. And trust me friends, this concept is actually very simple. If you understand the first problem, it's very simple. It doesn't take much time actually. If this concept is new to you, so you might face some problem. But yes, once you're done with 1-2 times practice, then it's very simple. So let us move on. Yes, one more thing that you need to remember. Sin t formula is a e raised to it minus e raised to minus it upon phi I. No other option you need to remember. And cos t is a e raised to it plus e raised to minus it upon 2. No other option. You need to remember this formula. No other option. Right? See the difference in the formula? If it is sine, then we have minus, and if it is cos, then we have plus. So this is the difference. And the second difference is in the denominator. Actually, it is 2i. So in the denominator we have 2i, and here we have 2. So with sine we have I, and with cos we don't have I. So you need to remember the formula. See here, let's check few variation. Whatever is the angle, that will go up. So here it is t, so here it is t. Suppose we have sine phi t, then what? If it is t, here it is t. If it is phi t, then phi will go up. So that will become e raised to phi I phi t minus I phi t upon 2i. Simple. Suppose you have cos 3t. So what will happen? So 3t will go up. So that will become e raised to I 3t plus e raised to minus I 3t upon 2. So you can have any variation. Whatever will be the angle, that will become your exponential part. With this knowledge, I can start with the problem. Are you clear with this? If not, pause this video, go back and check this. First of all, understand this, then only you can come to the problem, then you'll understand. So let's move on and let's discuss problem number 12. So here the problem number 12 is Laplace of sine raised to phi t. So that is Laplace of, in short, sine raised to phi t means what? Sine t raised to phi, right? So which is that? Sine t. What is sine t? See here. Sin t formula is e raised to it minus e raised to minus it upon 2I raised to 5. Yes, one more thing will be required. Again, these things you gonna copy on the last page of your notebook. Here we gonna write it down the power of I. If you are comfortable with the power of I, no problem. Not comfortable, make a note on the last page of your notebook. See what is I? I square. I square value is minus 1. Next, I cube. Always write in terms of I. So I cube in terms of I square. So I cube is what? I square into I. So that is this I square value is minus 1. So minus 1 into I is minus I. Next, I raised to 4. Always in terms of, we'll try to convert it into I square and I. So I square into I square. This I square is minus 1. I square minus 1. Minus 1 minus 1 will become 1. Next, I raised to 5. I square into I. So that will be minus 1 minus 1. That is 1 into I. So that is I only. And so on. You can go ahead. I raised to 6 is what? I square. Minus 1 minus 1 minus 1. That is minus 1. I raised to 7. I square into I. And so on. Right? So these things also required. You can copy at the last page of your notebook. So let's move on. Here it will be, see here, if I open the bracket, this will be 2 raised to 5, I raised to 5. Obviously, that will come out of the Laplace transform, 2 raised to 5, I raised to 5. So this will be 2 raised to 5, I raised to 5 inside e raised to it minus e raised to minus it upon raised to 5. 1 upon 32 into, this is 32, I raised to 5. See here, I raised to 5 is I, because I square I. So it will be I. Keep pen, paper, notebook, everything aside and full concentrate on board, because this simplification you need to see it very carefully. Once you understood this, then it's like piece of cake. So you need to have a full attention on board, please. So let's start. So obviously it's raised to 5. That means these are the coefficients 1, 5, 10, 10, 5, 1. Right? So let's start. So the first coefficient is 1. And what is the formula? First term raised to this power. So here the first term is e raised to it raised to this power. That means it's actually e raised to it raised to 5. With that, we have second term with raised to 0. The second term is e raised to minus it raised to 0. See here, the formula that we discussed is for plus. For plus, everything is plus here. Plus, and so on. But if it is minus, it will be alternate plus and minus. So in this formula it is minus, so it will be alternate plus minus. So here it is minus. Next coefficient, check the formula, it is 5. We're gonna reduce this. So this 5 will become 4. We're gonna increase this. So the 0 will become 1. You just need to reduce this and increase this. Next coefficient is 10. Again gonna reduce this. This will be e raised to it 3. We're gonna increase this, e raised to minus it 2. Alternate plus minus. Next coefficient is 10. We're gonna reduce it again. We're gonna increase this. Alternate plus minus plus. Next coefficient is 5. So we're gonna reduce this. That is 1. We're gonna increase this. Minus 1. Finally gonna reduce this. So e raised to it raised to 0. And gonna increase this. So e raised to minus it raised to 5. Is this clear? So let us open and let us simplify this. So this 1 upon 32i. It's actually very simple. See here. What do you mean by this? E raised to it raised to 5. This 5 will be multiplied with this. Right? This 5 will be multiplied with this and this will become 5it. It's very simple. See here. E raised to a into b is actually e raised to ab. These two terms will be multiplied. The same way, e raised to it into 5 will be multiplied and that will become e raised to 5it. or in short I phi t. And you know anything raised to 0 is 1, so that term is gone. Minus, here it is phi e raised to I 4t. See here, this is I 4t and this is e raised to minus it. Next, e raised to, this 3 will come, so that will become I 3t. This 2 will come inside, minus I 2t, minus 10. Again 2 and 3 will come inside, so that will become e raised to I 2t, e raised to minus I 3t. Next, plus phi e raised to it, e raised to minus I 4t, minus, this will become anything raised to 0 is 1, and this is e raised to minus I phi t. So let us further simplify it. Here 32 you can write it down as 16 into 2, that is perfectly okay, no problem. Right? So this is first term is e raised to I phi t. Next, minus, this is phi e raised to I 4t minus it. So if you multiply this two, this will be added. So e common, I 4t minus it will be I 3t. 4 minus 1 is 3. Simple calculation. 3 minus 2 is 1. That's minus 10. 2 minus 3 is minus it. Plus 5. It minus 4it, that is minus I 3t. 1 minus 4 is minus 3. And finally, is this clear? What next? Steps are fixed. First time if you are doing, you will find it a bit complicated, but trust me, it is much simpler than writing down sine square into sine cube for sine raised to 5. Next, first and last will be combined, second last and second will be combined, third and third last will be combined. What I said? First and last will be combined. See here. See here. First and last will be combined. See here. First and last. If you have done it correctly, the first term is I phi t and the last term is minus I phi t. This will be same. So here it is I phi t and the last term is minus e raised to minus I phi t. Next, first and last will be combined. See here, second last and second will be combined. Here it is actually e. Second last and second will be combined. So see here, it is I 3t, it is minus I 3t. So let us take minus 5 common. So if you take minus 5 common, here it will be e raised to I 3t. And if you take minus 5 common from this, you will be left with a minus e raised to minus I 3t. Here it is e raised to I 3t minus e raised to minus I 3t. Next, plus third and third last term will be combined. So let's take 10 common from this. So if you take 10 common, here it is e raised to it minus e raised to minus it. See here outside I have written 16. 2i, this 2i, I am taking inside. 2i is actually here, but I am taking it inside. Right? So if I take inside this 2i, here it will be 2i, here it will be 2i, here it will be 2i. This 2i I am taking inside. If I take inside, so here there is a Laplace. This Laplace is there in all the steps, right? Which is equal to 1 upon 16 Laplace of, see here, e raised to phi it minus e raised to minus phi it upon 2i. See here formula. What is e raised to I phi t minus e raised to minus phi t upon 2i is sin phi t. So this term will become sin phi t minus, what about this term? Phi. See here, if the angle is t, here it is t. If the angle is phi t, here it is phi t. See here, what is the angle here? Here angle is 3t, so therefore it will be sin 3t. Next, plus 10 into sin t. Why? Because here the angle is t. Is this clear? So we're left with the last step. See, I hope you are clear with the purpose. Why we did this? Because in the problem it was sin raised to 5, and obviously sin raised to 5 we can't manage. It must be converted into linear terms. So let's move on. 1 upon c, last final step, sin phi t Laplace is what? A upon s square plus a square. That is phi upon s square plus 25. Next. That's it. This is a formality step. Phi into sin 3t. Sin 3t Laplace. A upon s square plus a square plus 10. Sin t Laplace 1 upon s square plus 1. So this is your required solution for this particular problem. Is this clear? Yes or no? So pause this video and 2 minutes, 5 minutes, 10 minutes, just have a look. Try to understand. Go back and check. Try to understand what we did in this particular problem. In the same video, we're going to discuss one more problem, that is problem number 13, and that is sin raised to 5t. So with slight changes, I can convert this problem into sin raised to cos raised to 5t. Problem number 13. See here. First copy this. Problem number 13. The problem is now cos raised to 5t. See the changes. So here it will be cos. Here will be cos. Next. See here. There will be no I. This will be plus. But next. First of all, there is no minus. So everything will be plus. So here it is plus, plus and plus. What else? There will be no I outside. First of all, there will be no I in the problem. So there is no I in the problem. What next? There is no minus in the problem. So here it is plus. Sorry, this will be minus. In between it is plus. See here, once you understood the technique, you can easily manage the second problem also. Is this clear? Now we need to go ahead and the second last step we need to solve. So here it will be 1 upon 16 Laplace of, now this time it will become this cos t. So this will become cos phi t minus phi cos 3t plus 10 cos t, which is equal to, let us find it out, Laplace. This is 1 upon 16 Laplace of cos phi t s upon s square plus 25 minus phi into cos 3t is s upon s square plus 9 plus 10 cos t s upon s square plus 1. So this is the required solution. The only change, major change will be in the last step. Apart from that, there is no I in the problem and all are plus. This is also plus. So see here, if you understood problem number 12 with slight changes, you can easily manage problem number 13. And not only 13, you can see in the next videos problem number 14 and 15 are also similar to 12 and 13. So I prefer this technique because once you understood this technique, you can solve 4 problems of the same time. Is this clear? Because if you don't follow this technique, sin square t and sin cube t for sin raised to 5 will be some different trigonometry. Formula will be different. For this, you need to again use different trigonometry, and next 2 problems in the next videos, you need to use again the different trigonometry. So basically, what I want to convey, you can use Pascal triangle and can solve all the problems with the same technique. So hope this is clear. Practice well. In the next videos also, we'll be discussing the similar problems. Thank you.